give you a quick crash course on fractions and just the vocabulary that we use, what we talk about, what we have talked about so far in fractions, and just kind of like a quick overview of what your students should be able to do with fractions. So we've talked about equivalence, and all of them should know that equivalence means same amount. So, So are the fractions equivalent? Do they have the same amount or the same value? Are they equal? Number line, we'll talk about how to represent fractions on a number line. We've looked at that. You can use the number line as a tool to compare fractions. An area model is simply a fancy name for shape. So they can draw a shape or an area model to show if two fractions are equivalent, or to reason through the fact if one is bigger than the other. Comparing fractions, can they tell me if they're equivalent or which one is larger or smaller? And then partitioning is simply how many parts are in a whole of a shape or how many parts are in the entire number line. So the most basic thing that we start out with is I would give the students a fraction like 2/4, and I would give them a shape and say partition this shape to show 2/4. Or I would maybe even start even simpler and just say partition this shape into 4 equal parts. So I'm just going to put 4 equal parts. So then we have talked countless times about how you would start by making 2, and then you could split that half in half and that half in half to make 4 equal parts. Then they can label their 4 equal parts if they would like. So after they get that down, and then same thing for like thirds, then to make 6, after they split into thirds, they can just split those in half. So that way they're not splitting a shape to look like this, and then these parts are obviously smaller than these, and that doesn't give an accurate model. So we worked on just simply splitting shapes. They were also like circles or rectangles into the proper parts. And then on a number line, it would look like this, same exact concept. Split it in half. Always make sure that you label 0 and 1 or whatever your whole number needs to be. So now we know we have 1 part, 2 part of our number line, and so we'd have to split those in half again to get approximately the same number of parts. So after we partition, check on partitioning, then we would move to, okay, show me what 2/4 looks like in an area model. So then they would draw this rectangle shape again, and then they would maybe start by shading 2 parts, knowing that 1 part is 1/4, 2 parts is 2/4. So 2 pieces have been shaded, so the numerator shows how many parts are shaded, or in the case of a number line, how far has been traveled. We have traveled 2/4. And then the denominator always being the parts in the whole. So there are 1, 2, 3, 4 parts of the rectangle, and there are 4 parts dividing 0 and 1. So then we would know that 2/4 on the number line would be right there. So that's how you would show the number line or area model with just identifying a fraction. So then you could as practice, you could give them, okay, show me 3/8 on a number line, or show me 1/2, show me 3/6. Okay, you could just make up any fraction. We've mainly been working on halves, thirds, fourths, sixths, and eighths. So if you tell them 12ths, they should be able to understand, but these are the main ones that we've worked on, is halves, thirds, fourths, sixths, eighths. So then after that, we would move to giving them 2 different fractions. So for example, if I gave them 1/2 and 3/6. So then right here, they're going to tell me, is it greater than, is it less than, or is it equal to? I'm sorry, less than, greater than, equal to. So then they could do one of two things in showing that to me. They could give me, I'm going to use this as my 1/2 and this is my 3/6. They could draw an area model so they know that this would be half, and then we would have to split this one into 6, so then we have half, and then we would have to do 3 parts on this side and 3 parts on this side. That's not super even. There we go. Or I've also taught them to do like, okay, split into thirds first and then split each of those halves into thirds. So just as long as it's equal and they partition it equally, they can figure it out through an area model. So then for 1/2, we know that there's 2 parts in the whole and 1 part is shaded. There are 6 parts in the bottom from the denominator and 3 parts are shaded. So is that equivalent? Yes, those are equal. Then they would show me the equal sign. They could also use a number line, always marking 0 and 1. So for half, we would just split into 2 parts, and then we could do thirds, and then split each of those thirds in half. Those aren't super equal. That might confuse. That's about as good as I got. So then we know this would be 1, 2, 3, 4, 5, 6 parts. So the first one would be 1/6, 2/6, 3/6, 4/6, 5/6, and then we know this would be 1/2. So this is a good example because I didn't super take my time. So this, if we tried to find what's equivalent, it's not going to match up very well. So just always making sure that we're being precise so that we'll see that these two are equal and so that there's not any confusion with me not being precise with my number lines. So that often happens, but then we would be able to know with the number line that 1/2 and 3/6 are equal. I also love to talk to them about like if they're different, so like 3/8 and let's do 1/4. Or actually let's do 3/4. So 3/8 and 3/4. So we know that the numerators are the same, but the denominators are different. So we've talked about how if the numerators are the same, we have to go then look at the denominator, and we know that if we were to split a shape into 4 parts, those parts are going to be much bigger. So if we have 3 out of 4 parts shaded, that's going to be larger than 3 out of 8 parts because our 8 parts are going to be smaller. So they are more than welcome to show a picture similar to this one, showing 3/8 and 3/4. But I also like to talk to them about how, okay, without even drawing a picture, which 3/4 or 3/8 is closer to or over 1/2. So always using that 1/2 as a benchmark. So we know that 3/4, half of 4 is 2. So we automatically know that 3/4 is more than half of 4. And then what is half of 8? 4. 4/8 would be half of 8. So we know that this one is automatically below 1/2, and this one is automatically larger than 1/2. So we would know that 3/4 is greater than 3/8. You could also draw a number line or an area model. Last thing is you can always give students, like if I gave them 6 and thirds, I could say, okay, tell me what would you have to do to make these fractions equivalent. So how can you make these equal or equivalent? So then they would have to brainstorm and show me like what makes these equal. So with the thirds and the 6, so then they could draw a picture with thirds and then again with 6, making sure that those are lined up. So then we could say, okay, if I shade 1/3, that is equal to me shading 2/6. So then them generating those equivalent fractions. So then we would know those are equal. They also could put, 2/3 or 4/6, or they could even do 3/3 and 6/6 because both of those are equal to 1. So that's a little bit of a crash course on fractions. Again, let me know if you need anything additionally.